Hello everyone. So today we are going to talk about alternating current. This is the one of the most important topic in different kind of entrance test that you are going to take very recently. We know uh, this topic contains many informations and many understanding things so that you can crack answers of the entrance test questions. If you are discussing this topic, then you may find many mathematical calculations from this chapter. But in an entrance examination, generally very tricky and shortcut questions will be asked from this chapter. That's why to make you understand about the general idea of this chapter and making you confident about this chapter to take your entrance test and you get your name in merit list. We have been preparing this kinds of YouTube tutorial for you. And you should not forget one thing, that entrance tests are not difficult, but they are definitely tricky. So none of the questions in entrance test are going to be difficult if you have sufficient time. But in an examination, you will be suffered with time, and there is a huge pressure of getting your name in your merit list. That pressure definitely tries to bring you back. It tries to drag you back. Okay, at that time, you should be provided with substantial information and the general idea that makes you to get the correct option to tick in examination. So in even in alternating current, uh, different kinds of informations are there. You should understand them well, and as per that understanding you can easily crack the answer. यो च्याप्टरबाट कुनै डिफिकल्ट खालको क्वेसन चाहिँ सोधिँदैन. अभियसली कुनै पनि च्याप्टरबाट डिफिकल्ट क्वेसन सोधिँदैन, तर सबै क्वेसन्सहरू ट्रिकी चाहिँ हुन्छ. टाइम प्रेसरको कारणले डिफिकल्ट लाग्नु एकदमै स्वाभाविक पनि हो. Okay, so let us move on. Here I'm going to talk about the general idea of this topic in the beginning, and then I will follow up with the previous year examinations questions. So later on, you will see the questions from this chapter to be very easy. And obviously, the coming entrance test also will poses easy questions. Let's expect same. And obviously that happens because we teacher also know that students obviously will in pressure in examination. So let's begin here. So AC means alternating current whose magnitude will change continuously and polarity will change periodically. For your understanding, let me just draw a few information, few diagrams to represent AC. So this is your sinusoidal current. This is one of the type of alternating current. Similarly, sometime you may have this kind of current as well. So increasing, again change, polarity change. This is called sawtooth. Okay, the sawtooth is also alternating current. Sometime you may have this kinds of pulse. Okay, rectangular or square pulse. This is also your alternating. Generally, there is a great misconception in student is that the alternating current always means sinusoidal. It's not so. Sinusoidal is one of the alternating type. Okay, so if the magnitude will change continuously and the polarity will change periodically in a specific period, the polarity will change, then such type of current is called alternating current. So in contrast, the direct current means the magnitude and the polarity of the current will be constant. Okay, so is known to you. I just gave you a general idea about this alternating current and its definition. So the magnitude of the alternating current is very difficult to specify. अब यसको magnitude यही sinusoidal नै हेर्ने हो भने पनि यसको magnitude overall one cycle को लागि हेर्ने हो भने 0 हुन्छ. Okay, यो magnitude र यो magnitude equal opposite, यो magnitude equal opposite, यो magnitude equal opposite. So instantaneous value लिने हो भने it's so difficult to express. That's why यस्तो खालको magnitude लिँदाखेरि हामी half cycle को average गरेर लिन्छौँ. So I have prepared to talk about this one a bit later. Okay, so यस्तो खालको sinusoidal currentहरू मोस्टली हामीले यो टपिकमा डिस्कस गर्ने चाहिँ sinusoidal नै हो. त्यसैले sinusoidal EMF लाई हामी साइनको टर्ममा एक्सप्रेस गर्न सक्छौँ, जुन केसमा यो इन्स्टेन्टेनियस भ्यालु हो भने यो पिक भ्यालु भनेको यो भ्यालु है। सो इएमएफ जसरी इन्क्रिज गर्छ करेन्टको भ्यालु पनि त्यसरी नै इन्क्रिज गर्छ। अनि जेनरल यो चाहिँ नर्मल कन्डक्टरको केस हो, जेनरल रेसिस्टरको केस हो। यहाँ इन्डक्टर र क्यापासिटरमा कसरी चेन्ज हुन्छ भन्ने कुरा हामी भरे डिस्कस गर्छौँ। सो हामी साइनोसोइडल इएमएफ र साइनोसोइडल करेन्टलाई यसरी एक्सप्रेस गर्न सक्छौँ, जुनमा I naught and E naught are the peaks value of respective parameters. The mean value of AC for a complete cycle is 0. Okay, that's why we have to define a specific kinds of value that can represent alternating current without being 0. Okay, so your mean current दुई खालको छन् र mean EMF दुई खालको छ। यदि हामी चार्जको रिफरेन्समा है इन टर्म्स अफ चार्ज डिफाइन गर्छौँ भने त्यो भ्यालुलाई हामी मिन भ्यालु भन्छौँ। र मिन भ्यालु चाहिँ कस्तो हुन्छ भने मानौ हामीसँग कुनै एउटा अल्टरनेटिङ सोर्स छ, यहाँ अर्को कुनै डाइरेक्ट सोर्स छ। यो डाइरेक्ट सोर्सले गिवन टाइममा गिवन रेसिस्टरबाट गिवन सर्किटमा जति चार्ज पास गराउन सक्छ, ओके, त्यति नै अमाउन्टको चार्ज यो एसीले पास गराउनु पर्यो त्यही टाइममा त्यही सर्किटबाट। भने यो एसी को मिन भ्यालु यो डीसी को जुन कन्स्टेन्ट भ्यालु थियो नि, यो आई मिन भनेको त कन्स्टेन्ट भ्यालु हुन्छ, यसको चाहिँ अल्टरनेटिङ हुन्छ। मानौ यो हाम्रो अल्टरनेटिङ थियो, यो अल्टरनेटिङ पल्सले टी टाइममा आर सर्किटबाट जति चार्ज पास गरायो त्यति नै चार्ज पास गराउनको लागि चाहिँ यदि डीसी चाहिँ आई मिन भन्ने भ्यालु सफिसिएन्ट छ भने एट दैट टाइम दिस आई मिन डीसी भ्यालु इज कॉल्ड the mean value of this AC. Okay, this is how we define. So in terms of charge, we define the magnitude, that is mean magnitude of the AC, and it is found that it's nearly 64%, 63.7% of the peak value. Okay, and obviously in terms of EMF too it is so. RMS value चाहिँ generally हामी energy सँग र डेली लाइफमा पनि हामी आरएमएस भ्यालु नै युज गर्छौँ, किनभने मोस्ट अफ द टाइम हामीले युज गर्नुपर्ने चाहिँ इनर्जी नै हो है। चार्ज भन्दा इनर्जी सजिलो हुन्छ डिस्कस गर्नलाई र सजिलो हुन्छ युज गर्नलाई, त्यसैले इनर्जीको टर्ममा डिफाइन गर्छौँ। और हिट इनर्जीको टर्ममा, वर्क डनको टर्ममा भने त्यसको भ्यालुलाई इफेक्टिभ भ्यालु और आरएमएस भ्यालु भनिन्छ। जति पनि हाम्रो डेली लाइफमा आउने 220 भोल्टेज और 30 एम्पियर यस्तो भन्छौँ, यो सबै आरएमएस भ्यालु नै हो। र त्यो आरएमएस भ्यालु चाहिँ पिक भ्यालुको नियरली 71% है, 70.7 जति हुन्छ है, त्यो 71% को हाराहारी हुने भएको हुनाले we can easily write this one. You must remember this kind of questions can be asked to even calculate the peak value, or sometimes you will be given peak value and you will be asked RMS value or mean value. यस्तो information चाहिँ you should remember. The role of the resistor in AC as like in DC. So AC र DC रेसिस्टरबाट पठाउने भने AC यसरी AC पनि यो रेसिस्टरबाट पठायो भने यो अल्टरनेटिङ पल्स छ भने रेसिस्टरबाट अल्टरनेटिङ पल्स यसरी नै जान्छ। भनेको AC र DC उस्तै हुन्छ के को लागि, रेसिस्टरको लागि। इन्डक्टर र क्यापासिटरमा देयर इज समथिङ डिफरेन्स, देयर विल बी आइदर लीड और ल्याक अफ द current to the EMF. Okay, due to induction effect, this is very important. Due to induction effect in coil, AC flows through it, develops a kind of resistance that is what we call reactance. त्यसै गरी क्यापासिटरमा पनि चार्ज जम्मा हुन्छ, एउटा प्लेटबाट अर्को प्लेटमा चार्ज जम्मा गर्दा अभियसली डिफिकल्ट फिल गर्छ त्यो सिस्टमले फिल गरेको डिफिकल्टीलाई हामी रियाक्टेन्सको टर्ममा बुझ्छौँ। त्यसैले इन्डक्टरको केस होस् या क्यापासिटरको केस होस्, दुईटै केसमा एक्स्ट्रा रेसिस्टेन्स बिल्डअप हुन्छ जब एसी पास गर्छ। यु हेभ टु बी भेरी केयरफुल। डीसी पास गर्दाखेरि के हुन्छ हामी हेरौँला, एसी पास गर्दाखेरि एक किसिमको रेसिस्टेन्स प्रोड्युस गर्छ र त्यो रेसिस्टेन्स भनेको रेसिस्टरको जस्तो होइन है, रेसिस्टरको जस्तो होइन, आफै बिल्डअप हुने रेसिस्टेन्स हुन्छ, त्यसलाई हामी रियाक्टेन्स भन्छौँ। र obviously this is XC and XL, they are respective of kind, and unit obviously resistance हो भने ओम नै हुन्छ। AC through a resistor remains in phase. Remains in phase भनेको यो EMF को फेज हो भने करेन्ट पनि यसरी नै जान्छ है। यिनीहरुको दुईटाको बीचमा फेज डिफरेन्स एक्जिस्ट गर्दैन, त्यसैले त्यसलाई हामी इन फेज भन्छौँ। र equal to I naught sin omega t equal to E naught sin omega t हुन्छ। त्यसै गरी इन्स्टेन्टेनियस पावर क्याल्कुलेट गर्ने भने पावर हामीलाई थाहा छ, पावर भनेको p इक्वल्स टु vi हुन्छ है। सो p इक्वल टु vi, v को सट्टामा हामी अहिले EMF युज गर्छौँ, ei लेख्ने हो भने we can easily obtain this kind of information. This is widely useful while dealing with the energy consumption. Okay, यति हामी निकाल्न सक्छौँ र यसलाई सिम्प्लिफाई गर्ने भने 2 ओमेगा t हुन्छ। यदि फ्रिक्वेन्सी f छ भने यसको पावर चाहिँ 2f जति हुन्छ है, बिकज हियर इज 2 टाइम्स 2f जति हुन्छ है। द पावर फ्याक्टर अफ रेसिस्टिभ सर्किट इज म्याक्सिमम। पावर फ्याक्टर भनेको कति इनर्जी कन्ज्युम्सन गर्छ भन्ने कुरा हो। अभियसली रेसिस्टरको थ्रुबाट क्रस गर्दाले म्याक्सिमम वर्क डन गर्नुपर्छ, त्यसैले पावर फ्याक्टर अफ द रेसिस्टर इज 1। An inductor, the EMF leads the current by phase of 90 degree. Okay, so जहिले पनि EMF को पीक चाहिँ अगाडि हुन्छ है। सो यहाँबाट यसरी सुरु हुन्छ यो। सो EMF को पीक यहाँनेरि छ भने, EMF को पीक यहाँ छ भने करेन्ट को पीक यहाँबाट सुरु हुन्छ है। करेन्ट को पीक चाहिँ यहाँबाट यसरी सुरु हुन्छ, जहिले पनि 90 डिग्री अगाडि 90 डिग्री पछाडि रहन्छ करेन्ट। यो 90 डिग्री करेन्ट पछाडि रहनुको कारण छ है। हामीले जस्तो मानौ यो EMF सप्लाई गर्यौं केबाट, इन्डक्टरबाट भने इन्डक्टरमा अल्टरनेटिङ करेन्ट पास गर्ने बित्तिकै त्यसले ब्याक EMF निकाल्छ। त्यो ब्याक EMF ले यहाँ करेन्ट फ्लो गर्नलाई के गर्छ त, रेसिस्ट गर्छ। कति बेरसम्म रेसिस्ट गर्छ भन्दा जब करेन्टको म्याग्निट्युड अर सप्लाइड EMF को म्याग्निट्युड 90 डिग्रीसम्म पुग्छ त्यति बेरसम्म रोकिराख्छ, त्यसपछि चाहिँ यसले पास गर्न दिन्छ। त्यो भएको हुनाले फेज डिफरेन्स 90 हुन्छ भने करेन्ट जहिले पनि पछाडि 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 हुन्छ है, EMF अगाडि हुन्छ 90 डिग्री अगाडि। दुईटै फ्लो भइरहेको हुन्छ तर करेन्ट चाहिँ 90 डिग्री पछाडि देखिन्छ। र इन्डक्टिभ रियाक्टेन्स निकाल्ने हो भने यो हामीले क्याल्कुलेसन गरिसकेका छ अलरेडी। सो XL इक्वल टु ओमेगा L जति हुन्छ र अभियसली ओमेगा L हो भने XL इक्वल्स टु 2 पाई FL हुने भयो। सो इफ यु टेक अल दिस थिङ्स टु बी कन्स्टेन्ट, सरी 2 pi L will be constant, then obviously XL will be directly proportional to F. And if you just want to express in terms of graph, graph मा पनि सोध्न सकिन्छ। यो XL हो र यो फ्रिक्वेन्सी हो भने यो स्ट्रेट लाइन हुन्छ, यसलाई y इक्वल टु mx प्लस c ले रिप्रेजेन्ट गर्न पनि सकिन्छ। ओके, दिस इज द आइडिया अफ XL and frequency. So pure inductor blocks, okay, pure inductor blocks high frequency AC. You already have seen here, if frequency is high, XL will be very high. That's why resistance will be very high. If resistance is very high, then we can say it is open circuit. Similarly, for low frequency AC, okay, sorry, for DC को लागि frequency directly 0, XL को value पनि 0 हो भने DC can easily pass through this inductor. That's why this inductor will be widely used in rectifier circuit as a filter circuit. यसले AC पार्ट लाई ब्लक गरिदिन्छ भने DC पार्ट लाई जान दिन्छ। हाम्रो रेक्टिफायर सर्किट को पनि रेक्टिफायर मा फिल्टर को काम पनि त्यही हो, AC पार्ट लाई ब्लक गर्ने र DC लाई चाहिँ जाने दिने, सो दैट हाम्रो AC बाट के आओस्, DC आओस्। Okay, instantaneous power we can calculate this way. Okay, so this is another information regarding this one. In capacitance, the current leads the EMF by 90 phase. Okay, यसमा चाहिँ यस्तो। Okay, यहाँ let me just draw a diagram. जस्तो यो चाहिँ EMF भयो, यो EMF in inductor, यो चाहिँ current हो है, current in inductor, यो 90 डिग्री अगाडि हुन्छ, त्यसो 90 डिग्री ahead. But in case of capacitor, यो current हामी जहिले पनि रेसिस्टरकै डाइरेक्सनमा राख्छौं भने यो 90 डिग्री पछाडि हुन्छ। 90 डिग्री पछाडि हुनुको कारण एकदम सिम्पल छ। हामीलाई थाहा छ क्यापासिटरमा सुरुमै हामी चार्जिङ गर्छौं, चार्जिङ गर्दाखेरि करेन्ट ग्रो गर्न थाल्छ। त्यो चार्जिङले सुरुमै चार्ज एक्जिस्ट गर्ने भएको हुनाले सुरुमै करेन्ट एक्जिस्ट गर्छ, त्यहाँनेरि EMF पास गरेको होस् या नहोस् है। So this is how we can easily obtain the information. Similarly, the capacitive reactance, okay, this capacitive reactance is determined as the reciprocal of the product of this angular frequency and the capacitance. And if you just obtain this, and this XC will be inversely proportional to frequency. That's why if you just draw the graph between this, if your frequency is small, okay, if frequency is small, XC is very high. That's why the value of XC will decay like this one and remains asymptotic. Okay, this is your Xc and this is I. Oh, sorry, this is frequency. This is your frequency. This is how the variation of this will take place. Let's move on. Uh, okay, the pure capacitor will act as a short circuit. Okay, so if your AC is used and if your frequency is very high, so if F is very high, X is going to be 0. So if zero resistance is there, then that is what we call short circuit, and X acts as an open circuit for DC. If your frequency is 0, then X will be infinite. Infinite is like a open circuit. Okay, this is how we can easily obtain the general information about the working of inductor and capacitor for AC and DC. Okay, the power factor of the pure capacitor will be cos 90. Okay, so this is not pi only, this is pi by 2 actually. This is 90 degree. Okay, the phase difference is 90 because your current will be in this direction, EMF will be in this direction, the angle is 90 degree. That's why in case of pure capacitor and even inductor, okay, in capacitor and inductor, the power factor is 90 degree. So, well, cos phi is called power factor. This determines how much power is dissipated in circuit. Here, no power will be lost. Without power, the current can transfer through this capacitor or inductor if they are of pure kind. That's why sometimes we define wattless current in case of pure capacitor and pure inductor. Okay, let's move on to the next discussion about the general information of this. So for that one, let me bring you to the next frame. Okay, so in here, let's look at the other ideas. The impedance of LR circuit. Sometimes we can use L circuit and R circuit and so and so. So LR circuit is Z. This is impedance. The total impedance will not be as in DC. DC मा चाहिँ सिधा सिधा जतिवटा रेसिस्टर जोडे पनि जस्तो R1 plus R2 यस्तै यस्तै हुन्थ्यो है, सिधा सिधा जोड्न पाइन्थ्यो. यसमा सिधा सिधा जोड्न पाइँदैन. इभन L र R चाहिँ के हुन्, सिरिजमा हुन् है. सो R स्क्वायर प्लस XL को स्क्वायर यसरी हुन्छ र स्क्वायर रुट एन्ड अभियसली यो हाम्रो इन्डक्टर हो. इन्डक्टरमा त भोल्टेज लिड गर्छ र यिनीहरू दुईटाको भ्यालुले डिटरमाइन गर्छ फाइको भ्यालु है, आर र एक्सएल को भ्यालुले. हामीलाई थाहा छ R by XL is going to be tan inverse of this is going to be your phase difference. Okay, so phase diagram बाट हामीलाई थाहा छ, यसको म जनरल आइडिया भनिदिन्छु. जस्तो हाम्रो मानौ यो चाहिँ EMF छ, यो हाम्रो यो चाहिँ लेट्स से यो फेज फाइ छ, यता हाम्रो यो R छ और VR भयो, यो VL. ओके, लेट्स से VL VL छ भने VL बाइ, सो 10 फाइ भनेको VL बाइ VR हुन्छ. त्यसैले XL बाइ R हुने भयो, यति चाहिँ हुने रहेछ है. I thought I wrote wrongly previously. XL by R will be the phase, and this phase is always positive because the EMF is leading in there. Okay, so this is the idea of the magnitude of the phase difference. Okay, so let's move on. In case of LR circuits, phase difference I will mention in here as well. This is XL by R, and the power factor will be given by this one. So यही डायग्राममा है, यो XL यता VR. ओके, यहाँ VL लिने हो भने हाम्रो cos phi को भ्यालु निकाल्न सकिन्छ नि. यो phi हो, सो यहाँबाट cos phi को भ्यालु निकाल्न नि यसको भ्यालु निकाल्नु पर्यो, यसको भ्यालु निकाल्नलाई यो दुईटा जोड्नु पर्यो है. सो cos phi भनेको नि हाम्रो यो फेजर डायग्रामबाट आरामले निकाल्न सकिन्छ. ओके, लेट अस मूव अन. For CR circuit, we can calculate exactly in the same way the value of phase and the power factor. So if in case of pure capacitor, pure inductor, these value are going to be 90 degree. Okay, these are the things related to this one. And furthermore, we are going to see the impedance. Okay, in this case of this LCR circuit, the same reactance type of parameter is understood as this impedance, and this impedance can also be calculated as R square plus omega L minus 1 by C omega square. यो कहिलेकाहीँ उल्टो पनि हुन सक्छ है. सो हामीले ओमेगा एल XL को भ्यालु ठुलो लियौं भने यसरी लेख्नु पर्छ XC को भ्यालु ठुलो लियो भने 1/C ओमेगालाई अगाडि लेख्न पाइन्छ सो हामी इजिली यो गर्न सकिहाल्छौँ र यहाँ किन माइनस नै हुन्छ इट्स सो इन्ट्रेस्टिङ सो VL यता हुन्छ VC यता हुन्छ है सो अभियसली डाइरेक्सन लिने हो भने त पोजिटिभ डाइरेक्सन लिने हो भने यो पोजिटिभ डाइरेक्सन मान्छौँ हामी यसलाई है VL माइनस VC नि गरेर लिनुपर्छ त्यही भएर हामी यो सब्ट्र्याक्ट गर्छौँ फेज निकाल्ने हो भने यसरी निकाल्न सकिन्छ ओके सो द टोटल म्याग्निट्युड निकाल्नु पर्यो भने कहिलेकाहीँ क्वेसनमा सर्ट क्यालकुलेसनमा यसरी दिन सकेको हुन्छ यसरी यो एकदमै आरामसँग निकाल्न सकिन्छ यो प्यारामिटर्सहरूलाई this is the general idea of this one okay the reciprocal of the resistance of AC is called susceptance reciprocal of resistance is called susceptance and the reciprocal of impedance is called admittance एकचोटि यो क्वेसन सोधिसकेको छ है के भन्छ भनेर यो रिजोनेन्सको कन्डिसन एकदम इम्पोर्टेन्ट छ द्याट्स वाइ आई एम गिभिङ फोकस इन हियर सो ड्युरिङ द टाइम अफ रेजोनेन्स XL will be equal to XC दुईटै बराबर हुन्छ यो दुईटा बराबर भएको केसमा यो 0 भयो भने डाइरेक्टली फाइ पनि के हुन्छ 0 हुन्छ यदि यो XL XC बराबर हुन्छ भने यो टर्म 0 हुन्छ यो टर्म 0 हुन्छ भने Z will be equal to कति हुन्छ राइट सो Z will be equal to R सो यदि Z को भ्यालु नै R जति भयो यो भन्दा सानो त हुन सक्दैन सो यो केसमा Z will be minimum if Z will be minimum then current goes maximum in case of resonance Z will be minimum current will be maximum and VL र VC को भ्यालु जोड्ने हो भने चाहिँ फेरि 0 हुन्छ है VL plus VC is going to be exactly 0 and the circuit is purely resistive because you will have here only the effect of resistor that's why the circuit is purely resistive circuit मा phase को भ्यालु cos phi को भ्यालु cos 0 हुन्छ है cos 0 भनेको 1 भयो त्यसैले म्याक्सिमम पावर डिसिपेट हुन्छ करेन्ट पनि म्याक्सिमम फ्लो गर्छ करेन्ट म्याक्सिमम फ्लो गरेपछि हामीलाई थाहा छ करेन्ट म्याक्सिमम फ्लो हुन्छ भने हिटकै टर्ममा हेर्ने H² = I² RT करेन्ट म्याक्सिमम भयो अरे हिटिङ म्याक्सिमम भनेको वर्क डन म्याक्सिमम भन्नुको मतलब चाहिँ पावर डिसिपेसन पनि के हुन्छ त म्याक्सिमम हुन्छ यो रेजोनेन्सको केसमा र रेजोनेन्सकै केसमा हामी के युज गर्न सक्छौं भने यो रेजोनेन्स फ्रिक्वेन्सी कति हुन्छ भनेर निकाल्न सक्छौं ओके सो यो हाम्रो यो XL XC छ नि XL XC will be acting as a forced oscillator यो आफ्नै यसको नेचुरल फ्रिक्वेन्सी हुन्छ अनि बाहिरबाट दिएको हाम्रो जुन EMF हुन्छ सप्लाइड EMF XL र XC ले गर्दा यसको आफ्नो नेचुरल फ्रिक्वेन्सी डेभलप भएको हुन्छ यो E ले के गर्दिन्छ फोर्स्ड भाइब्रेसन जस्तो काम गर्दिन्छ र फोर्स भाइब्रेसनले अभियसली के गर्छ त resonance create garcha if the frequency are going to be matching with one each other okay maximum power will be dissipated. I will discuss this and this is widely used in case of radio transmitter receiver and other and even in the transmission of the signal in Wi-Fi as well we require a use bandwidth for that one okay choke coil use garchau हामी जुन बेला पावर कन्ज्युम्सन कम गर्नु पर्छ है पावर कन्ज्युम थोरै बनाउनको लागि चाहिँ हामी चोक कोइल युज गर्छौं चोक कोइल युज गर्नुको कारण सिम्पली चोक कोइल भन्ने बित्तिकै यो प्युर इन्डक्टर हो प्युर इन्डक्टरमा पावर फ्याक्टर 90 डिग्री हुन्छ सरी पावर फ्याक्टर 0 हुन्छ cos phi will be 0 त्यसैले विदाउट पावर करेन्ट फ्लो गर्छ है थ्योरेटिकली विदाउट पावर हुन्छ किनभने कोइल हो कोइलमा त आफ्नै के रेजिस्टेन्स पनि होला त्यसको कारणले हामी प्र्याक्टिकली यो cos phi को भ्यालु 0 त भेट्दैनौं इट क्लोज टु 0 तर थ्योरेटिकली विदाउट पावर करेन्ट विल फ्लो थ्रु द pure coil that's why choke coil हामी युज गर्छौं पावर रिडक्सन गर्नको लागि र यही यो रिजोनेन्स भएको कन्डिसनमा एउटा सर्किटको इफिसिएन्सी नाप्ने प्यारामिटर छ त्यसलाई हामी क्वालिटी फ्याक्टर भन्छौं which can easily be calculated as this one either voltage across VC by VR भने पनि भो or VL by VR भने पनि भो यो प्यारामिटरलाई हामी त्यो सर्किटको क्वालिटी फ्याक्टर भन्छौं र त्यो क्वालिटी फ्याक्टरलाई सिम्प्लिफाई गर्ने हो भने रेजोनेन्सको केसमा मात्रै हुन्छ है बी केयरफुल क्वालिटी फ्याक्टर अलवेज बी मेजर्ड इन टर्म्स अफ रेजोनेन्स यस्तो हुन्छ र डाइमेन्सन अफ दिस L/C CNR √LC all these are of time okay and one more thing if you are just figuring out about the current in circuit at any time in LCR circuit then current grows or current decays as per this one हामी चार्जिङ गर्दैछौं भने यहाँ प्लस लिन्छौं डिस्चार्जिङ गर्दैछ भने माइनस लिने हो, करेन्टको भ्यालु घट्दै जान्छ र इन्फाइनाइट टाइममा मात्रै यो चाहिँ म्याक्सिमम हुन्छ या 0 हुन्छ। चार्जिङमा म्याक्सिमम हुने हो, डिस्चार्जिङमा यो 0 हुने हो र त्यसले लिने टाइम चाहिँ infinite. Okay, all these things are the general idea about the AC. Now we will be following up with the MCQs that had been asked in the previous examination. Okay, so which one is the quality factor of LCR circuit? So obviously we already have seen LCR circuit ma resonance condition ma quality factor नाप्छौं र quality factor determine गर्छ तीनटै प्यारामिटरले। जब आर को भ्यालु सानो हुन्छ त्यति बेला क्वालिटी फ्याक्टर के हुन्छ त ठुलो हुन्छ। क्वालिटी फ्याक्टरले शार्प रेजोनेन्स डिटरमाइन गर्छ। आर को भ्यालु स्मल हुन्छ भने आर को भ्यालु यसरी फ्ल्याट भयो भने यस्तो खालको हुन्छ है। आर को भ्यालु ठुलो भयो भने शार्प रेजोनेन्स डिटरमाइन गर्ने चाहिँ यो रेसिस्टेन्स हो र obviously यो L by C हुन्छ। This is gonna be the correct answer. Okay, so this is the correct answer for this one. Let me just write in here. Next is, in purely resistive AC circuit, the current resistive circuit भनेको छ। रेसिस्टिभ सर्किट भनेको त्यो रेसिस्टर जस्तो बिहेभ गर्छ। अनि रेसिस्टिभ सर्किटमा त करेन्ट र EMF एउटै फेजमा हुन्छन्। जुन फेजमा करेन्ट पुग्छ त्यही फेजमा EMF हुन्छ। इज इन फेज विथ EMF, अरु केही नहेर्ने, एकदम स्ट्रेट फरवर्ड क्वेशन छ। इन फेज, दे विल बी इन फेज विथ वान इच अदर। लीड पनि हुँदैन, ल्याग पनि हुँदैन। ओके, नेक्स्ट इज, in LCR circuit having L hit 8 Henry C 0.5 R AT connected in series produces a natural angular frequency. So this is interesting one. Okay, this is a very short mathematical calculation type of questions. LCR circuit with natural frequency जब म्याच गर्छ त्यही बेला हाम्रो रेजोनेन्स हुने हो। त्यसैले हामीले निकाल्नु पर्ने भनेको यहाँ 1/2 पाई under root L र C नै हो है। is asking about the natural frequency. So 1/2 पाई सधैँ छ, यो 1 / LC, L भनेको 8 छ अनि C भनेको कति छ? C भनेको 0.5 into 10⁻⁻6 भनेको 5 into 10⁻⁻7 भयो। ओके, सो यहाँबाट यसलाई सिम्प्लिफाई गरेर निकाल्ने हो भने यु क्यान इजिली गेट द भ्याल्यु। यसलाई 8 पंचे 40 यहाँनिर 40 भइहाल्यो, 40 into 10⁻⁻7 है। सो यस्तो भयो। 40 लाई पनि बाहिर ल्याएर 2 बनाएर ल्याउने है, 4 हुन्छ। त्यसपछि यो 10⁻6 मात्रै भयो है, यो 10⁻⁻6 मात्रै भयो। यहाँ भित्र पनि यस्तै सर्टकट क्याल्कुलेसन गर्ने हो है। सो 1/4 पाई हुन्छ हैन, 1/4 पाई into 10⁻6, यो सबै डिनोमिनेटरमा छ। सो यो 10⁻3 भयो माथि जाँदा हैन, अनि 1/4 पाई भयो। सो 1/4 भनेको 0.25 भयो, 0.25 into 1000 भयो के, यो 1000 अनि 10⁻3 भनेको 1000 भयो। सो 1000 को 0.25 भनेको कति हो? 1000 को 0.25 भनेको 1000 को 0.25 भनेको 250 भयो। 250 लाई फेरि पाइले डिवाइड गर्नु छ है। सो यु क्यान इजिली गेट, आई बिलिभ it might comes in the order of like your okay 300-400 radians. Okay, you can easily calculate the calculation. The shortcut गर्न चाहिँ एकदमै हामीले जान्नु पर्छ, otherwise so tedious. Even you are provided with small kinds of calculator, then you can easily do this kinds of mathematics. जति सजिलो मेन्टल क्याल्कुलेसन हुन्छ त्यति इजी चाहिँ यो क्याल्कुलेटर गरेर साह्रो हुँदैन है। So let me just calculate for shortly and then I'll tell you the answer. Okay, okay, I just did the calculation with my cell phone and I got this value to be this one. Okay, so next, an inductive coil has a resistance of 100 ohm. Coil ma pani आफ्नै resistance हुन्छ नि है, this one, and as frequency is 100 Hz feeds to the coil, the applied voltage leads the current by the phase of 45 degree. Then the inductance of the coil is approximately, okay, so resistance दिएको छ, frequency दिएको छ, phase angle दिएको छ. If all these informations are given to you, then at that time, so your calculation is going to be so easy. You just need to put all these parameters there and obviously you are gonna get the result value. Okay, so let me just calculate this one. Okay, so you are given this frequency and inductance of the coil is asked. So if your frequency is 1000, then what is the inductance? Okay, the inductance is, XL equals to omega L. So simple calculation. And here the inductive coil has a resistance of this. So coil is producing some resistance. That's why in place of this one, you can just put 100 and omega is 2 pi F times L. So if you just do the simple calculation, then from this calculation, you are going to get, I believe, let me just use my cell phone and obtain this one. Okay, so this comes about 16 millihenry. Okay, so this is the general idea about this one. The simple kind of calculation can also be asked sometime. So a wire of 200 kg has a capacitance of dash and frequency of 10 kilohertz. What is the inductance when the impedance is minimum? Okay, so impedance minimum हुने भनेको situation हेर्नु पर्यो है, impedance minimum, and you are going to calculate the inductance, the value of L again. So let me just simplify these questions in here with the simple mathematics. See, we have to calculate the inductance in impedance minimum. Impedance minimum कुन बेला हुन्छ त, जुन बेला resonance हुन्छ है. So resonance हुने बेलामा XL equals to XC हुने. And you know well, you are given 200 kg of wire and its resistance is like this one. Sorry, capacitance is this one. That's why total capacitance is going to be 0.0014 into 200. Okay, so I believe this comes in the order of like 2.8 into 10 to the power minus 7 farad, in the order of this one. Okay, so this is a microfarad. That's why we have to multiply all these things. So you will get the value of this one. So in minimum impedance, your XL will be equal to XC. That's why you have to use this information. So obviously you are given 50 kilohertz. Be careful while dealing with this. Kilohertz means 1000 times more. Okay. So use all these things and obtain the simple calculation. For your calculation, I just use my cell phone to get it, and I will tell you the parameter shortly. Okay, so the magnitude for this one is nearly 0.368. Okay, so the most promising answer for this one is going to be 0.37. Okay, so let's move on. Another question. In RC circuit, the charge on capacitor when being discharged is maximum. Maximum कुन बेला हुन्छ डिस्चार्ज गर्ने केसमा? जुन बेला हामी डिस्चार्ज गर्न सुरु गरेको हुँदैन, डिस्चार्ज गर्न सुरु गर्ने बित्तिकै और जस्ट स्विच अन गर्दाखेरि म्याक्सिमम चार्ज हुन्छ, अनि टाइम बढ्दै जाँदा चार्जको भ्यालु घट्दै जान्छ. त्यसैले इन्फिनाइट टाइममा त 0 हुन्छ. यहाँ क्वेशनले म्याक्सिमम भनेको छ. म्याक्सिमम भनेको मतलब के हो? यसको स्ट्रेट फरवर्ड आन्सर, स्विच अन, जस्ट स्विच अन गर्दाखेरि यसमा म्याक्सिमम हुन्छ. यसको मतलब हो टाइम इक्वल टु 0 इन एलआर सर्किट. एलआर सर्किट रिकल गरौँ, भोल्ट एल र आर छ. एल भनेको लिडिङ हो, इएमएफ लिडिङ. करेन्ट एन्ड भोल्टेज आर इन फेज, अभियसली होइन. करेन्ट लिड्स द भोल्टेज, करेन्टले लिड गर्ने क्यापासिटरमा हो. भोल्टेज लिड्स द करेन्ट. ओके, voltage leads the current by the phase of 90 degrees. This is promising answer. Let's look at the final one. Current leads the voltage by a phase of pi. This is not the correct answer. So this one is your correct answer. This one is your correct answer for these all. Okay, let me move on to another frame. Just before that, let me erase the answer of these questions that I've just done you so far. Okay. Okay, let me move on to another frame. Okay, let me move. See here. Next. See this one. Again, here some questions are related to simple calculation. AC voltage, EMF of this, and then current is flowing is this. The capacitance is this. Okay. Then the current flowing through the capacitor. You have to calculate the current. Current calculate गर्नको लागि हामीलाई के चाहिन्छ त भन्दा EMF by resistance. Resistance कहाँबाट आउँछ? Resistance को भ्यालु यहाँ यो क्यापासिटरबाट फ्लो गर्दैछ. क्यापासिटरबाट फ्लो गर्दैछ अनि you just need to calculate the value of capacitive reactance. Capacitive reactance निकाल्न you require omega and C. Omega कहाँबाट आउँछ? Omega आउने भनेको यहाँबाट है. E equal to E naught sin omega t cos omega t. यसरी हामी रिप्रेजेन्ट गर्न सक्छौं. So represent गर्ने हो भने from here you can get the value of omega frequency. So just get current flowing through the capacitor of the capacitance this much. Okay, you just need to put the all parameters. So your current is going to be equals to EMF by the reactance. Okay, you just need to put all these things. So on putting all these things, we can get values. Let me just calculate shortly. So this is your 100 because your RMS value will be E naught by root 2. So if you just divide by root 2, this is your 100. And this one is going to be 1 by 2 pi and frequency is there. Okay. So your frequency is going to be 10 and so you can easily get this 10 and all this 100 110 power minus 6 and so, and if you just simplify, I just obtain this as a 1 ampere. This is not a milliampere, rather ampere. Okay, so the value can be easily be calculated this way for this question. Okay, let us move on to another one. Let me just write the correct answer for this. Okay, next, the resonance frequency in LCR circuit is this one. All these things are given to you. You just need to put the value of L, C, and R. Then obviously we are going to get the value of resonance frequency. So your R को value चाहिँदैन. Say you 0.8 or 0.5 ला multiply गरेर निकाल्ने हो भने you can easily get the value of this resonance frequency for this particular questions. I did not do calculation. You can easily do it with your calculator. If the resistance in AC circuit is increased, then the power factor resistance is increased. Okay, resistance increase गर्ने हो भने resistance increase गर्छौं भने obviously power को value बढ्दै जान्छ. Power factor will be cos phi will be directly proportional to R. Okay, R by something हुन्छ नि different case मा. त्यसैले it is directly proportional to R. That's why obviously resistance बढाउने हो भने यसमा increase हुन्छ. It's a logical question. The resonance frequency of the circuit is F. If the capacitance is doubled, then the new frequency will be, okay, capacitance is doubled 1 by 2 pi under root L by C. Okay, previously it is related to F. If you just make it 2, then it's like your 1 by 2 pi under root LC with 1 by root 2. Okay, previously it was your F. Now it is F by root 2. So this is gonna be your correct answer. Okay, let me just write the answer here with another column so that you can just figure out this. Okay, next is an AC having angular frequency. Angular frequency means this is your omega, sorry, angular frequency F is passed through a capacitor of this. What is the capacitive reactance? You can just easily multiply. Capacitive reactance means omega C. Okay, X equals to 1 by 2 pi F C. So you can just multiply all these parameters and you can easily get. I did not do calculation because this video is getting so longer. Next, at a resonance, the effective resistance of LCR circuit is effective resistance. I already told you, XC पनि XL अर्काले neutralize गर्छ भने effective resistance will be minimum. It's not 0. It is equal to R. This is your correct answer. Okay, minimum चाहिँ हुन्छ. Minimum चाहिँ हुन्छ, 0 चाहिँ हुँदैन. The power dissipated in AC circuit depends on. केमा depend गर्छ त? Resistance, capacitive reactance, inductance, impedance and inductive reactance. So यो सबै यहाँ राखेको छ यस्तो खालको है. सबभन्दा इम्पोर्टेन्ट कुरा, power dissipation in AC circuit will depend upon resistance. Resistance मा चाहिँ डिपेन्ड गर्ने हो. यसले कति पावर कन्ज्युम गर्छ भन्ने कुरा. This is a kind of very straightforward questions. Okay, let me move on to another frame. So I have plenty of questions still left. Okay, so this one is for a highly inductive circuit. The power factor is highly inductive. Be careful. Highly inductive is like a inductor. Inductor मा के हुन्छ power factor? Minimum हुन्छ, अझ 0 हुन्छ. Highly inductive को केसमा is going to be 0. Okay. Metal Dewar detectors uses the principles on diffraction होइन, interference पनि होइन, bit frequency sound को. यसको answer पनि so easy. This is your alternating current pulse. The average power of LCR circuit dissipated through AC circuit is, so this is a well known. You know, power factor is P equals to P naught times cos phi. Okay, so if it is your P equal to P naught times cos phi, then obviously P भनेको is related to RMS. That's why this answer is correct for this one. अरु यो I लाई मात्रै multiply गरेर भएन, I र I multiply गर्ने हो भने त यो, this is something new. This is very incomplete here. Only current here, current, EMF, cos phi, all this is so barbage. In AC supply, 30 volt runs 30 volt RMS which feed to the pure resistance of 10 ohm. The power dissipated in this. Okay, so 30 volt is supplied there. 30 volt is supplied and resistance is 10. Okay, and you have to calculate the power dissipation. This is RMS value, and you are asked feed on a pure capacitor. So just you need to get what is the important thing is power dissipation is RMS power into cos phi. यहाँ cos phi को value कति हुने? Pure resistor को केसमा cos phi को value is going to be exactly cos phi is cos 0 and cos 0 means this is 1. Okay, so obviously the answer is okay. So you can just do the calculation. This is 900 by 10 is your 90. So this is what we do for the minor calculation. Okay, so this is your 90. Okay, this is your 90. In AC circuit, the power loss takes place through definitely power loss गराउने भनेकै सबभन्दा इम्पोर्टेन्टली रेसिस्टरले हो, अरूले त पावर लस गराउँदैनन्. प्युरको कुरा गर्ने हो भने त इन्डक्टर क्यापासिटरले केही नै गर्दैन. A coil of inductance this much resistance this and is connected to a battery of this. The current in the coil is 1 ampere at approximately time. We are going to get the time. Okay, so यहाँनिर हामीलाई भेट्नु छ के भन्दाखेरि the current in the circuit. So अघि सुरुमा मैले एउटा फर्मुला युज गरेको थिएँ, probably you still know for charging and for discharging all the things. सुरुमा हाम्रो करेन्ट कति छ? I naught maximum value भनेकै, so maximum value simply यो 12 volt छ ब्याट्री, 12 volt ब्याट्री बाट करेन्ट सप्लाई गर्दा यो रेसिस्टेन्स अनि 6 ले डिवाइड गर्ने is going to be 2. Okay, so we can easily get this one I naught, value of I naught. र I naught use गर्ने हो भने यो I naught use गरेर, so I equals to I naught e को power RT by, okay, RT by L भन्ने यो फर्मुला युज गरौँ and the connected, okay, the current in coil is 1 ampere at approximately time. Battery जोडेको छ, battery जोडेको छ भने it's getting charging. Okay, so यो हामीलाई थाहा हुने भयो So I by I naught, I by I naught. You I को value 1 राख्ने है, because we have to get this to be 1. So we have to use here 1 by 1 by I naught को value हामी निकाल्न सक्छौं 2 e को power e को power plus r time by हामीलाई time निकाल्नु छ है, divided by all these parameters are given to us, and as these parameters are provided to this. Okay, if you just do a math, simple calculation by putting all this value in a calculator, I believe the value would come in the order of this 1 millisecond. Okay, let me move on to another. In Nepal, the supply of AC is 220 volt, the peak value. So this is RMS value. I already told while dealing the discussion. So 220 lai फेरि root ले multiply गर्ने, this is nearly 311. The best answer option is here 310. Okay, 311 जति हुन्छ. Best answer यही. The EMF 15 volt is applied to the current containing 5 ampere inductance and 10 ohm resistance. The ratio of time infinite to time equal to 1 second is. Okay, current निकाल्नु छ जुन time infinite भएको बेला त maximum हुन्छ है. So हामीलाई ब्याट्री सप्लाई गरेछ, ब्याट्री सप्लाई गरेको छ भने टाइम इन्फानाइट भयो भने इन्फानाइट टाइम हुँदा त म्याक्सिमम हुन्छ I इक्वल टु आई नट हुन्छ है, त्यो आई नट हो म्याक्सिमम र 1 सेकेन्ड हुँदाखेरि. इन्ट्रेस्टिङ छ यो है. यसको क्याल्कुलेसन गर्ने हो भने you just use the same formula I by I naught equals to e power चार्जिङ के केस हो है, चार्जिङ को केस हो भने I. Okay, let me just write with another pen. Okay, I by I naught भनेकै म्याक्सिमम हो, यो 1 हो, 1 सेकेन्ड को केस को हो. यो e को पावर RT by L. If you use this calculation, okay, if you use this calculation, you are going to get this. I already have done this mathematics so far. So you simple mathematics. So you can easily obtain the value of this to be this one. Okay. So this is the simple calculation type of problem you can obtain from there. Let us move on to another frame. I believe the last frame is going to be shown to you. I'm trying to make it shorter because getting so longer. Okay, let me move on to the last frame. There are a few questions still. Okay, the admittance of the alternating current is defined as the reciprocal. Admittance, be careful, not susceptance. Admittance is the reciprocal of impedance. This is the correct answer. If the capacitor of the circuit is increased, capacitance of the circuit is increased. Okay, the reactance of the capacitor increase, current will decrease. Reactance of capacitor will increase and current increase, definitely it will not happen. Resistance of capacitor, reactance of capacitor will decrease and current is decreased. The capacitance of the circuit will increase. If the capacitance will increase, so obviously capacitive reactance will increase. Capacitive reactance will increase. Okay, if the capacitance reactance will increase, if capacitive reactance will increase, let me just look at it. So 1 by omega c. If the capacitance is increased, Xc will decrease. Okay, this is so interesting. The Xc will decrease. If Xc will decrease, Xc decrease हुन्छ भने Xc को value decrease हुन्छ भने current को value के हुन्छ? Increase हुन्छ, because this is like a resistance. If capacitance is increased, if capacitance of the circuit is increased, then reactance will decrease. If reactance will decrease, then the current will increase. This is gonna be the best answer for this one. Power dissipated through a purely inductor circuit when current through this. Okay, this is very simple. You know well, the magnitude of the power dissipation in L and I is going to be 1 by 2 Li squared. This is a straightforward question. Okay, the inductor L and resistor is this in series with the battery of this, and the rate at which the energy will be stored in the form of electric field. Okay, I believe this should be in magnetic field. Oh, sorry, This is the energy stored in the form of electric field is. Okay, let us calculate for this one. Let us do a simple mathematics for the value of Z. The impedance is equal to the resistance for DC, and obviously for maximum power dissipation. Okay, so maximum rate at which the energy is converted means power means, so this is so simple, E squared by R plus R. This formula is already known to you, and if you just do the mathematics, then R will also be equal to R for maximum power. So okay, this will be the formula. Okay, so we can easily calculate this kinds of thing from here. Okay, now let us move on to another. The inductance L and resistance R are connected to the battery of E. Okay, we already have done this. Okay, the capacitive reactance for DC. Capacitive reactance for DC. Capacitive reactance. Xc will be equal to 1 by 2 pi f C. So C is 0. So it is going to be infinite. The very straightforward answer. A choke coil is a choke coil should have choke coil. Choke coil means the device that lowers the power consumption. Okay, should have a high reactance and low resistance. High resistance and low inductance. High inductance, definitely it's not. Low resistance and high inductance. Obviously choke coil त तारले बनेको हुन्छ, केही न केही त रेसिस्टेन्स हुन्छ नि, हामी रुल आउट गर्न सक्दैनौँ। एकदमै थोरै रेसिस्टेन्स भयो र हाई इन्डक्टेन्स भयो भने इनर्जी कन्जम्सन चाहिँ मिनिमम। Okay, so these are the common thing that we have done so far. Now we reach the end of this discussion. Thank you all, and we will be meeting in another discussion. Thank you all.